Welcome to the deep dive. Today, we're getting into something really practical, something many of us might experience but maybe don't quite see. Those wireless signals coming from, well, everywhere around us, especially our neighbors.
Right, the invisible neighborhood, you could say.
Exactly. And we're looking at a specific, really interesting case study. It comes from Neil over at EMF Safety Zone. He moved into a new apartment and ran right into this issue.
Ah, the close quarters problem. Wi-Fi routers, cordless phones, all broadcasted.
Precisely. So our mission today is to really unpack how he identified the problem, this unwanted radio frequency radiation, or RF, and then the genuinely surprising DIY solution he came up with. We'll look at the issue, his method, and crucially, the results he got.
And it's a great way to maybe understand a bit more about this RF radiation itself. What is it? Why is it something people are, increasingly curious or even concerned about, especially when we're all living closer together?
Okay, let's unpack Neil's story then. It really starts with something probably pretty relatable if you've ever lived in an apartment complex. You move in, you settle down, and then you realize, wow, my neighbor's tech is right there.
Just a wall away.
Yeah. For Neil, his neighbor's wireless router, just 15, maybe 20 feet away,
Yeah.
sending its signal straight through his bedroom wall.
That's very close range for a device like that.
And it wasn't just that. Another neighbor, this time impacting his office space, had a cordless phone and wireless internet that Neil said was just blasting into the room.
Blasting, huh? That's quite a description.
It really paints a picture. And get this, it was actually causing him headaches. Real physical symptoms from these invisible signals. How does that even, happen?
Well, what's fascinating here is how proximity works with these signals. Think of RF like ripples in a pond spreading out. They get weaker further away, obviously.
Sure.
But when the source is only 15 feet away through a standard apartment wall, those ripples haven't weakened much. They can still carry significant energy into your space. And for some people, that constant amplified exposure, well, it seems it can translate into noticeable effects like headaches or other sensitivities, prompting them to find ways to reduce it.
So Neil's feeling this, getting headaches. You'd think, okay, time to buy some expensive shielding paint or special fabrics.
That's often the go-to assumption, yeah. Specialized materials.
But here's where it gets really interesting. Neil took a completely different path, super accessible. He went to the hardware store.
Ah, I like where this is going. Simple material?
Exactly. The main thing he used, just standard metal aluminum screen, like you'd use for windows or doors. He bought it in these big rolls,
Yeah.
12 feet long by 4 feet wide.
Just plain aluminum screen. Okay.
Yeah. And he basically decided to, well, shield his apartment walls with it.
So how did he actually apply it? Just tape it up?
He tacked it onto the outside of his apartment walls, even wrapped it around the corners.
Outside? Huh. Okay, wrapping corners make sense for continuity.
Right. And he put it over the windows too, but the screen mesh still lets air through, which is clever.
Keeps the airflow. Yeah, good thinking.
And here's a key detail he mentioned. He made absolutely sure that wherever there were different sections or maybe layers of screen, they were touching each other, physically connected.
Ah, okay. That points towards creating a conductive enclosure, like a Faraday cage effect, basically.
Is that what it is?
That's the principle, yeah. A Faraday cage is essentially a container made of conducting material, like metal mesh. It blocks external static and non-static electric fields, and in this case, electromagnetic radiation, like RF signals. The mesh size has to be smaller than the wavelength of the radiation you want to block.
Okay, that makes sense. So the aluminum screen, connected all around, forms this kind of cage. But he did one more thing. Grounding.
Ah, yes. Crucial step. How did he do it?
He took a piece of copper wire, bolted it directly to the aluminum screen structure he'd made. Then he attached that wire, using a hose clamp, to a copper pipe.
Standard copper pipe.
Yep. And then he just knocked that copper pipe into the ground outside, connected the whole shield directly to the earth. Why is that grounding part so vital?
Well, grounding is absolutely essential. Without it, the screen itself, while it might block some signal, could also act like a big antenna. It intercepts the RF energy, right?
Right.
But where does that energy go? If it's not grounded, it can build up on the screen or even re-radiate, potentially inside the space you're trying to protect.
Oh, okay. So it could almost make things worse, potentially.
It might not perform effectively, let's say. Grounding provides a safe path for that intercepted energy to dissipate straight into the earth. It completes the cage and ensures the shield works properly to actually block and drain away those unwanted signals. It's not really a complete shield without it.
Got it. So the setup is complete, aluminum screen, connected, grounded. The big question then is, did it actually work? What did his measurements show?
Exactly. The proof is in the pudding, or in this case, the RF meter readings. This is where we talk about attenuation.
Attenuation. That means reduction, right?
Yeah.
Signal strength reduction.
Precisely. You measure the signal strength before and after the shield is in place. Neil was using microwatts per square meter, which is a standard unit for power density of RF radiation. He mentioned looking at both peak and average readings.
What's the difference there?
Peak is the highest burst of signal detected, like a spike, while average is the sort of constant background level over time. Looking at both gives you a really good picture of the RF environment.
Okay, so the results. In the bedroom where that neighbor's router was so close, before the screen, Neil said the reading inside the bedroom was, quote, just as strong as it was outside.
Wow. So basically the wall wasn't doing much to stop it.
Apparently not. But after he put up the screen, he measured, and again I'm quoting, 95 or 96 or 99% attenuation.
That's huge. Almost complete blockage.
He said his meter showed basically 0 microwatts per square meter, peak or average, registering inside. It was completely quiet.
Incredible. That's a dramatic difference.
And what about the office, where he was getting headaches from those blasting signals?
Yeah, the cordless phone and Wi-Fi combo.
Same story. After the screen went up outside that wall, the meter inside was, again, completely quiet. And importantly, the headache issue. It went away. The reduction in the signal seemed to directly alleviate his physical symptom.
That's a powerful outcome. The subjective feeling matches the objective measurement reduction.
So what does this all mean for you listening right now if you're in a similar boat, maybe feeling overwhelmed by neighbor signals?
Well, the main takeaway is pretty striking. Significant RF shielding doesn't necessarily require super expensive specialized products.
Right.
It can actually be achieved using common, relatively inexpensive materials you can find at a hardware store. Neil himself said this DIY approach was not terribly expensive and definitely cheaper than buying, say, special RF shielding curtains or fabrics.
It really puts a potential solution within reach for a lot more people, doesn't it?
Absolutely. It's empowering. It shows that with a bit of ingenuity and understanding of the basic principles, you can take tangible steps to modify your immediate environment.
So if you are living in close proximity, apartment, townhouse, even a house in a dense neighborhood, and you're concerned about the Wi-Fi or cordless phone signals bleeding into your space, this method, Neil's method, offers a real, practical, potential solution to explore.
It certainly does, and it prompts a broader thought too, doesn't it? This raises an important question.
Which is?
How can we apply these basic principles, shielding with conductive materials, ensuring continuity, proper grounding? How can we apply those ideas elsewhere? Are there other areas in our lives, other devices, other situations where these simple physics concepts could be used to manage invisible fields?
That's a great point. It makes you think differently about materials and their properties.
Yeah, it moves beyond just Wi-Fi in apartments. Maybe it applies to how we set up home offices or even think about cars or other enclosed spaces.
Right. So, wrapping this up, this deep dive really highlighted how something as ordinary as aluminum screen, if you use it correctly, continuous, touching, properly grounded, can be a surprisingly powerful tool against unwanted wireless signals.
It's a fantastic example of accessible science in action.
It really is an aha moment. You can potentially do something about these invisible intrusions without breaking the bank or needing an engineering degree. It's about empowerment.
Absolutely. And maybe it leaves you with this thought to consider. We're surrounded by these unseen waves, this electromagnetic environment. Neil's story shows how one common material had an unexpected shielding capability. What other everyday materials around you might have surprising interactions with these invisible forces? What could observing your own surroundings, maybe with a bit of this knowledge, inspire you to discover or even experiment with?